Okay, picking up where we left off, we're on page 223 talking about the four major categories of the things you would do in a database. Viewing the data, modifying the data, storing and retrieving data, and then producing reports. That's basically what this is all about. I want to go back to schema one more time. So in the definition that I choose to use, the schema is essentially a listing of what the thing looks like. So for example, here is a schema of some sort describing a particular table. And it talks about who the author is, the date, the description, the file, and all the rest of the stuff, and all these things. It's basically describing each one of these things, that there's a name, an order, a mode, a member, and all these rest of these things. Okay. So it could be used as like a record of how the database was put together. But in more modern, well, practically all databases now, the schema can be used for another feature. You can actually ask your database to produce a script that you can play back that will build the database from scratch. In other words, not only is it a documentation of each of the tables and records and fields, not only is it documentation, you can also tell it to create a file that will build them over. So in other words, I could give you a schema file. You could take it home and run that script on your machine, and it would build the database structure. Now, it wouldn't have any data in it, but it would have all the tables and all the relationships, all the fields. Everything would all be put together, because this is everything there is to know about it. Okay. So kind of mixed into here is some terms we need to talk about. So it's kind of scattered about. But there are three categories of SQL statements. And let's go through them. The first one is what's called the Data Definition Language, DML. The Data Definition Language is the one that's used for, DDL, Data Definition Language. Okay, I got it. It's right there on the screen. And this is a set of instructions that can build tables and drop tables and add columns and attributes. So it's the stuff that you use to create the database. Now, if you're not a database administrator, it is likely that you would never use a DDL command, because you would never create a table or drop a table. You'd probably just using tables that other people have already built and populated. Okay, so that's one of them. The other one is the Data Manipulation Language, the DML. Data Manipulation Language is all about how do I pull data from. This is all the query statements and all the rest of that stuff. So I'm adding to a table, I'm selecting a table, doing all those things. So my data manipulation. And then last, a third one, which is not in the book, but might be on a test question, is a thing called a data control language. And data control essentially means this is how I assign permissions. I go in and I say, Bob has permission to, I grant to Bob the delete permission for this table, or the insert permission for this table, or the modify permissions on this table. I go through and I tell it permissions. So DDL is for creating, DML is for getting data into and out of the database, adding, deleting, modifying, and then the data control, the DCL, is all about granting permissions or revoking permissions. Okay. Next thing we need to talk about is this thing called the data dictionary. Data dictionary is kind of sort of like that description of the schema thing over again. Except that, let's say for example, you have a big company and there's an awful lot of people who, there's four different people, or organizations rather, four different organizations that are trying to build this database for you. Well, in the warehouse, people, they call the part numbers part no, PARTNO, part no. But the accounting people call it part number, and the sales people call it part with a pound sign. So don't you think maybe all three of them ought to get together so that when they're talking about part number, that they're using the exact same word. And perhaps it's part underscore number or part no or whatever. As long as you're consistent, you'd be okay. And further, when you're building a table, one guy makes part numbers, 16 characters long, but the other guy says, well, I don't know how long those guys are. Let's use 12. So they make it 12 characters long. So it's the name of the field, the width of the field, everything else you need to know about the stuff. So this is something that people would come to, because I've been in databases where there'll be an abbreviation. It'll say, GMT, yes. And I'll go, I have no idea what the hell a GMT is. So I go to the data dictionary and look up what that definition is for that 3-letter acronym. So this is what this thing is all about. This data dictionary is not really inside the database. It's probably like in a 3-ring binder or a Word document. Give me a break. But in other words, it's not inside the database. And there's actually a person, usually called a data administrator, not database administrator, a data administrator, who's a non-technical person who's going to be responsible for maintaining the data dictionary. This is the person you would go to, say, I'm getting ready to build a table, I'm getting ready to link 2 tables, and I'm not familiar with this table. You'd go to there and look to see, what all those fields are and what they all mean. Okay, cool. That's what this data dictionary is all about. Okay. They talk a little bit about this access to the database. So here's, inquiries by management. I have some other software and have some applications. So I'm talking directly to the database management system. I'm logging into Oracle, or I'm logging into Microsoft SQL Server directly and asking a question, and it goes to the actual database and comes back. Or perhaps I've written a front-end application that talks to the database management system that goes to the database. So here's an application program that talks to the database and goes there. The bottom line is the physical layer is not touched by the user. Nobody, not people in this area, no one talks to the data directly. It all has to go through this database management system. And the reason is this guy plays traffic cop. If there's 2 people trying to modify the same, an attribute in the same table at the same time, like I'm changing Bob's street address and you're changing his telephone number, okay, at the same time, and both of us on the count of 3 hit the enter key at the same time, boom. This traffic cop has to decide how to deal with 2 different edits to the same record at the same time. That's why, and if somebody bypassed it, well, then all hell will break loose. So essentially, no one has access to the physical path to the database. It's all just going through this logical thing. Whew. Okay. So, query by example. This is just a graphical way of producing a query, and we're not going to bother with it. Instead of writing, select table from blah, 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 you drag and drop cool things and click some stuff. A lot of people find this easier to do. Okay. The next thing we're going to talk about is the actual... Wait a minute, I skipped something. Let me get down here. I thought we were at the end. I guess we are. Okay. So let me go through this traffic cop scenario one more time. So what are the roles of this traffic cop? Well, it has several roles. One is user authentication and authorization. So what's the difference between authentication and authorization? Authentication means prove you are who you say you are. Authorization means, okay, now that I know who you are, here's what you're authorized to do. So authentication, authorization. The second one is concurrency control. If 2 people try to talk at the same time, what do I do? What are the rules for, making things happen that way? And it acts as that interface between the users and the data, because nobody talks to the database directly. Okay, now I'm ready to move on. Now we're going to talk about the human parts. What are the roles? Database administrator. Once again, I kind of mentioned this is probably one of the most highly paid positions in IT, and probably for good reason. Now, admittedly, there's not that many of them out there. An organization may have 2. You may have like 30 or 40 programmers, but you're probably going to have 2, database administrators. So highly skilled, lots of experience, and have taken a heck of a lot more courses than just this course. Okay, so the database administrator basically runs the database. They're the ones who create the users, assign permissions, that authorization kind of thing we just talked about. Then they talked about what's the system administrators. And system administrators essentially just run the server. They're responsible for, keeping patches on the server and that kind of building user accounts, but not necessarily going into the database and doing anything. And then the data administrator. Once again, the data administrator is not necessarily a technical person. This could be practically anyone whose job it is to coordinate among all the users of the database to make sure that part number is always abbreviated the exact same way on every single report, and that if you have a 3-letter acronym in there, that somebody knows what the heck that thing means. So that's the data administrator. So that's kind of that piece. Next, they talk about the popular database management systems. So there's a bunch of them out there, and they have some really good ones out there that are now open source and free. MySQL, been around for quite some time. Maria, which is kind of a spin-off of MySQL. SQLite, there's a bunch of these guys, and I know $1 million companies that are running off MySQL. Well, we're not talking about no, this is good stuff. There's no real. The only real disadvantage, of course, in MySQL is that because it's open source, there really isn't a company behind it. And if you're trying to, and this is going to sound stupid, so don't get this wrong, but if you want somebody to be financially responsible, like in a lawsuit, you want to hold somebody financially responsible for the database, well, then you probably wouldn't go for open source. Okay, Microsoft Access, Lotus Approach, Google Base, and Open Office Base. These are all those little ones that are designed for single user or maybe 1 or 2 users, but don't go much further than that. The big boys: Oracle, DB2, Sybase, Microsoft SQL Server. Those are the big boys. And yes, there's some big ones out there. I use one of these guys from years ago. And then the NoSQL. There's a couple of these out there that I've heard of. Typically, you'd have to be in a special environment. Not every company is going to have a need for that big data kind of thing. Okay. The next thing we need to talk about is how these things could be configured. It could be that these things are configured in what's called a distributed environment. Well, not that guy and that guy. Well, actually, some of these. So, Oracle, SQL Server, MySQL don't have to all run on a single physical server. And so let's say you're in a scenario where this data is extraordinarily important to you. What you would probably do is have a database in this building, and then maybe a database in some other building a little further away. And you would have it coordinated so that every single record that goes over here also gets replicated to this other site. And if you're really, really paranoid, you'd have these things like in a different state. Like a tornado or a flood goes through. Having it one building over isn't going to help much, right? So this distance between these replicated servers, could be a mile or could be thousands of miles. All right. And the idea is that distributed systems have fault tolerant. So if one system goes down, the other one just says, "Hey, I got it. You guys go work on the other system because I've got it. I've got all the data, and the only thing you'll notice is the system might be a little slower than usual, and that's about it." Mini servers, perhaps, and then and you get to pick how fast you want that replication to occur. You could have it so that every time I store, the machine just says, "Hang on a second," and then does the replication live, and then says, "Got it." In other words, it doesn't return back to tell you okay until after the replication has occurred. That's one type. And the other type is kind of lazy, where I store a record, and then on its own, it just kind of goes. And so I could possibly miss something, possibly. So like if you're a bank and you're dealing with people's money, maybe that first type of replication is the way you want to go. This is a good place to start for the 15-minute mark. We'll pick this thing up in just a few.